Linear regression in AI. Beginner level. Introduction. Artificial intelligence. AI and machine learning systems often need to predict numerical values based on data. One of the most basic and widely used algorithms for this purpose is linear regression. Linear regression is commonly used in applications such as house price prediction, sales forecasting, stock price analysis, temperature prediction, business trend analysis. It is usually one of the first machine learning algorithms beginners learn because it is simple and easy to understand. What is linear regression? Linear regression is a machine learning algorithm used to predict continuous numerical values by finding a linear relationship between variables. In simple words, linear regression equals predicting numbers using a straight line relationship between variables. The model attempts to find the best line that fits the data points y equals mx plus b. Y equals mix plus b, m, b, minus 10, minus 8, minus 6, minus 4, minus 2, 4, 6, 8, 10, minus 10, minus 5, 10. Y-intercept, x-intercept, where y equals predicted value, x equals input variable, m equals slope, relationship strength, b equals intercept, starting point. This equation represents a straight line relationship between input and output. Example of linear regression. Consider predicting house prices based on house size. House size, square ft, price, 1,200, 1,500, 2,300. Example concept. House size means linear regression model means predicted price. The model learns that larger houses tend to have higher prices. How linear regression works. Linear regression attempts to find the best fit line through the dataset. Example concept. Dataset means find best line means minimize prediction error. The algorithm adjusts the values of m, slope, and b, intercept, to reduce prediction errors. This process is called model training. Visual concept of linear regression. Imagine plotting the data points on a graph. Example concept. Data points means best fit line means prediction line. The regression line shows the general trend in the dataset. New data points can then be predicted using this line. Example. Study hours versus exam score. Dataset. Study hours exam score, 240, 460, 680. Example concept. Study hours means linear regression model means predicted score. If a student studies 5 hours, the model may predict a score near 70. Simple linear regression. Simple linear regression uses one input feature to predict an output. Example. House size means predicted price. Only one independent variable is used. Multiple linear regression. Multiple linear regression uses multiple input features. Example dataset. Size bedrooms price. 1,202,200. 1,503,250. Example concept. Size plus bedrooms means regression model means predicted price. Multiple variables help produce more accurate predictions. Linear regression workflow. Typical workflow. Dataset. Down pointing arrow. Data pre-processing. Down pointing arrow. Train linear regression model. Down pointing arrow. Evaluate model. Down pointing arrow. Make predictions. This process is common in machine learning pipelines. Example Python code. Example linear regression using Python. From sklearn. Linear_model import linear regression. Model equals linear regression. Model.fit. X_train. Y_train. Here, fit trains the regression model using the dataset. Libraries such as scikit-learn, TensorFlow, and PyTorch support regression models. Advantages of linear regression. Linear regression has several benefits. Simple to understand, easy to implement, computationally efficient, useful for identifying relationships between variables. Because of these advantages, it is widely used in data science and machine learning. Limitations of linear regression. Despite its usefulness, linear regression has limitations. Assumes a linear relationship between variables. Sensitive to outliers. May not perform well with complex data patterns. In such cases, more advanced algorithms may be required. Real-world applications. Linear regression is used in many industries. Real estate. Predicting house prices based on property features. Business analytics. Forecasting sales and revenue trends. Finance. Analyzing relationships between economic variables. Healthcare. Predicting patient health metrics. Concepts learned from linear regression. Understanding linear regression helps beginners learn. Checkmark how machine learning predicts numerical values. Checkmark how relationships between variables are modeled. Checkmark how regression algorithms work. Linear regression is one of the most fundamental algorithms in machine learning. Simple definition. Linear regression. A machine learning algorithm used to predict numerical values by modeling the linear relationship between input variables and outputs. Final summary. Linear regression is a fundamental supervised learning algorithm used in machine learning and artificial intelligence. It predicts numerical values by finding the best fitting straight line that represents the relationship between input features and output values. Linear regression can be simple, one variable, or multiple, many variables. Because it is easy to understand and implement, it is often the first algorithm beginners learn when studying machine learning.